viewers, welcome to my YouTube videos on high physics vlogs.
Hello, good morning students. Today another important question for the class 11 junior inter. The question is in the concept of heat concept, thermodynamics. Here the question given here is derive the relation between Cp and Cv, or simply we can say Mayer's relation, or in other words the question may ask like this also: derive the relation between two specific heat capacities of gas on the basis of first law of thermodynamics. That is the question. Here in this question we have to consider a system. System means cylinder with movable piston. So this is a cylinder, this is a piston which will be movable. It will move inside and outside. Here this is, we can call it as the system. This we can call as the system. So inside it consisting of gas. So generally here in this case you can get the definitions of Cp and Cv. So how can you define the Cp and Cv? That means Cp means specific heat at a constant pressure. So the definition for this will be simple definition. So at a constant pressure, the amount of heat required for 1 mole of a gas to rise its temperature through 1 Kelvin or 1 degree centigrade. 1 Kelvin is called specific heat at constant pressure. In the similar way, Cv also there, that is specific heat at constant volume. So we can say the definition: at a constant volume, amount of heat required for 1 mole of a gas to rise its temperature through 1 Kelvin is called specific heat at constant volume. So where capital R is called the universal gas constant, its value is 8.314 joule per mole Kelvin. So in terms of calories you can say 2 calories or 1 point something, that is approximately 2 calories, better to use. See, how can you get the relation between Cp and Cv? First of all, here I am consider 1 mole of an ideal gas contained in a system containing cylinder with movable piston. Let A be the area of this piston. Inside the gas, ideal gas is there. That's 1 gram of ideal, 1 mole of ideal gas. This gas having the values initially pressure P, volume V, and temperature T. Okay. Now you can apply to here. That is, at a constant volume, what happened? At a constant pressure, what happened? Generally, the gases depends on pressure and volume. If the volume is constant, pressure will be changed. If the pressure is constant, volume will be changed. That is the basic phenomena for the gases. Here at a constant volume, so that means volume constant means piston does not move. If some heat is supplied to this, dq heat is supplied to this, then what happened? Automatically the temperature will be rises. So say the rise in temperature, let us say dt. Here heat is given, so this given heat totally utilized for increase in the internal energy only using for internal energy, represented by the symbol of du. So that means heat is supplied. There is no motion of no moving of this piston. That's why we can say work done is not there. So in this case we can say work done is equal to 0. Heat is given, but total heat will be absorbed by the gas molecules. So that is internal energy. The temperature rises dt. Now as we know that heat loss are gained from the principle of method of mixtures or law of calorimetry, we know the formula Q is equal to ms delta T is the formula for that. Now apply this same formula here. So that means dqv, that is at a constant volume heat is applied is nothing but internal energy du only. So you can apply this formula. M means mass, so that is 1 mole, you can say simply 1. S means specific heat at constant volume, that is Cv. Delta T, rise in temperature, is as you know dt. Now from this we can write here simply du is equal to Cv dt. So keep in mind, let it be equation 1, let us say. Now apply this at constant pressure, what happened? Now at constant pressure, same here I am using the same one. So at constant pressure, heat supplied to the system dq at a constant pressure. Now what happened? Pressure is constant means automatically initially the volume is say let V1. Now pressure constant means volume will be changed. That means piston will move outwards. That means this is the displacement. Now total volume will be V2. Now you can say the change in volume here is change in volume how much? That is simply you can say dV is the change in volume. Okay. dV is the change in volume. See, at a constant pressure, heat supplied can be utilized in two ways. One is for internal energy, another is to do the external work done. That means you can write here at a constant pressure, temperature increases to, as usual, temperature increases to dt. It is used to increase internal energy, du, and to do external work done. So work done is here. That is you can say dW. Now heat supplied, so dq at a constant pressure, which is nothing but simply dq. Okay, now same you can apply the same formula here. Q is equal to ms delta T. Now m means mass 1 mole, S means specific heat at constant pressure, that is Cp, rise in temperature as usual dt. That means you can write here dq is equal to Cp dt. Let it be equation number 2. Now here I am considering ideal gas. Okay, so as we know that you can write here from first law of thermodynamics. Dynamics, as you know that dq is equal to du plus dw. Okay, now substituting this 1 and 2, you will get from 1 and 2, substituting dq means what? Cp dt, which is equal to du means Cv dt plus dw. So dw, now from ideal gas equation, so from ideal gas equation, as you know that PV is equal to nRT. N means 1 mole means you no need to write. PV is equal to RT. So at a constant pressure, you can write PdV is equal to RdT. Okay, here work done is equal to, this is nothing but dW. dW is equal to PdV is equal to RdT. Simply you can place, in place of dW you can put RdT. So substitute in above. So what you will get? Cp dt, keep it this side, minus Cv dt is equal to dW. In place of dW you can put PdV or RdT. So dt cancel. Finally you will get Cp minus Cv is equal to R. This is the simple relation for the relation between the specific heats, capacities of gas or molar specific heats. So simple answer for this. So you can apply For the competitive point of view, you can get some formulas related to this. So in better to no need to write in the public exam point of view, board point of view. For the exam competitive point of view, it will be helpful to you. As you know that Cp by Cv is equal to gamma, ratio of specific heats, or simply Cp is equal to gamma Cv. Now substituting here, what you will get? Gamma Cv minus Cv is equal to R, or simply you can write Cv is equal to R by gamma minus 1. This is one formula you will get. Similarly, in place of Cp, in place of Cv, R by gamma minus. That is Cp is equal to gamma R by gamma minus 1. These are the two important formulas for the problem point of view. Thank you for watching.